In this problem we are given two charges of mass m and 2m having charge plus q and minus q. Obviously there will be an attraction force between these two charges plus q and minus q. Mass of the charges are m and 2m. Distance between the charges is 2r. So what is asked here is find speed of approach of above two charges when separation between them reduces to r. जब इन दोनों चार्जेस के बीच की दूरी 2r से कम होकर के r रह जाती है, यानी कि जब सिचुएशन कुछ ऐसी हो जाती है, ये चल रहा होगा किसी v1 स्पीड से, ये 2m मास चल रहा होगा इस ओर किसी v2 स्पीड से, एंड डिस्टेंस बिटवीन दीज टू इज लेट्स से r. देन हमसे पूछा गया है स्पीड ऑफ अप्रोच बताइए, जो कि होगी v1 प्लस v2. दिस इज द स्पीड ऑफ अप्रोच, राइट. तो इसके लिए हम दो चीजें लगा सकते हैं, एनर्जी कंजर्वेशन और कंजर्वेशन ऑफ मोमेंटम. एनर्जी कंजर्वेशन इसलिए वैलिड है क्योंकि फ्रिक्शनल फोर्सेज या अदर टाइप्स ऑफ लॉसेज आर नॉट अवेलेबल इन दिस प्रॉब्लम, राइट. सो initially momentum of the system was 0. Finally the system's momentum is mv1 minus 2m v2. This is negative because the v2 is in leftward direction, right. So from this what we get is v1 is equal to 2 v2. So this is the result we got by conservation of momentum. One more thing can be applied here, and it is conservation of energy. By conservation of energy, initial energy of the system, kinetic energy of the system is 0. Initial potential energy is k q minus q by 2r. Final kinetic energy will be half m v1 square plus half 2m v2 square. We know that v1 is equal to 2v2, so we can put the value of v1 as 2v2. So what we get here is half m 4 v2 square plus m v2 square. So 3m v2 square is equal to, and one more term is also there, which is the potential energy k q minus q by r, right. So 3m v2 square minus kq square by r, and this is minus kq square by 2r. So by moving it here, kq square by r minus kq square by 2r is equal to 3m v2 square. So kq square by 2r is equal to 3m v2 square. v2 is kq square by 6mr and under root. We know that v1 is equal to 2v2. v1 is equal to 2v2. So v1 is equal to 2 times kq square by 6mr under root, and velocity of approach in this case will be v1 plus v2. So this is 2 and this quantity in root, and this is 1 into this quantity in root. So the speed of approach will be kq square by 6mr into 3 and under root. So this is the final answer to above problem.